Welcome back to the University of Queensland School of Architecture series of introductory videos for Rhino and Grasshopper. Now we're going to pick up this variable core routine again. Now in the previous video we saw how we generated the core dimensions from a single point, and we created through here the geometry for the actual core outline, and here we're actually starting to put together the routine where we're going to scale up and extrude these cores, but also do them as a series so that they vary according to the rise. So we're going to have low rise, mid rise, and high rise banks of lifts. Now we've set up the floor to floors and the number of levels. That's generated our overall height or maximum height of the core, and through here we've also put in a scaling factor between the total number of levels and the floor service per lift core, and we put a rounding figure there to give us a whole number. Now this then will give us a factor that we can then use to scale down the maximum height of the core, and then create a series so that we can do one as a small, medium and large. Okay, so what we'll do now is that we'll now duplicate the core geometry. So we'll establish a series through here, and we'll do the number of duplications through here based off the same number coming out of this scaling factor through there. Now I've set up a variable here which is the spacing of the cores, so I'll show you what happens if we pop this in through there, and we're going to do a move. So if you notice here we're in the Y direction, so we're going to duplicate it this way. So we'll get a unit Y, and we'll get a move, oops, M-O-V-E, move. So that's the translation vector, that's the direction and the amount, and we want to move the geometry which is up here. So you can see here it's pulling up the number here, so it's duplicating it 4 times, and it's spacing them 3 meters apart. Now I've put a scaling there because, you know, theoretically you want to have space between the cores so you can actually get into the lifts. So we can do that through here. Now there's probably different options you can do, because typically a lot of lifts are banked back to back, whereas I've got them separated one out. And I guess you could do that through the variable through here, or by a weave and splitting the routine and then weaving the cores one on the other. So this is a kind of a more basic version of the variable cores, but if you get the general gist of it, you should be able to adapt it for your own needs. So what we're going to do then is establish the extrude height for each core, and we're going to do that as a series like we've done here. So we know the count, so let's just do let's pull up a series first through there. So the step value is going to be the value that we've generated from the overall height of the core scaled back according to our rounding factor there. So that's going to be our step value, and our count, I'm going to put an addition in through here. So where's our number? Through, I'll show you why actually. So if we can do the series through here, and we can just pop the count in through there, and if we go extrude, and we're going to extrude this as a Z value because it's going up, so the geometry is going to be these cores that we've duplicated through here, so that goes in there. We've got the series running through there, and then what you can see, there's our variable cores, but we've got a tiny problem, and sometimes this is the issue of the parametric routine, and you need to sort of tweak it a bit, because our first one is not being actually extruded at all, and you can see why. If we pull up a panel here, pop up that series there, when we generate the series, it's always starting as a 0 level. Okay, now there's probably a number of ways that we can start off at the first level, but I'm going to do it this way because that's the way I've decided to do it. So I'm going to add an extra step in the series. So I'm going to get my count number, put that into a simple addition. I'm going to add 1 to it, put that in the count, and that will give us then the height through there. So that's actually, so if we come back here, that will be, so our overall core height should be 291 meters, and you can see here that's 291 meters. So the maximum core height is correct now, but the issue is that it's still starting at 0, and because we've got 4 values coming in referencing coming into well, we got 5 values, sorry, still coming into 4 values, we get a superimposition on that final one. So what we're going to have to do is remove this index from the list, and we can do that quite simply by just doing a cull index, and we want to remove the index value 0, so we'll put a panel up, put a 0 there, we'll scale that back, pop that in there. So we'll get then the series going into here, and if we put a panel in there now, what you'll see is that it's popped this 0 value out, and now we're actually starting with a value, the second value in the list. So basically we've just sort of cut that first 0 value out. So now once we pop that list into the translation vector, voila, we actually have a functioning routine. So the neat thing about this routine is that, you know, it's a reasonably elegant solution. It's fully parametrical, so the heights will vary. We can sort of, as we pop down the number of levels, you can see our cores starting to drop away, and if we amp up the number of cores, you can see they'll actually drop away the number of cores, but the cores will become taller. So it gives you a lot of flexibility in how you can control the cores in your building. And because it's coming off a single point seed, what you can do is, just by paying attention to the X and Y values, how you set up the core length, and even if you put an orientation plane at that 0 point or the seed point, you can pretty much integrate this into any tower orientation that you might have. So I'll leave it there. The routine's a little bit messy at the moment. The final seed routine that you'll find online will be a cleaned up version of this with some notes and so on. But good luck, and feel free to use and adapt this tool in your project. Thanks.